Welcome to Elementary Algebra, Chapter 17. The author is Harold Jacobs. I'm your presenter, Molly Crocker. This is the promised free Chapter 17, the nicest, kindest introduction to number sequences and series. Lesson 1. Did you read the lesson? Most of this lesson is about wrapping your brain around some terminology for this topic of sequences. A sequence isn't an equation that draws a line or a curve. Sequences may be graphed, but each term of a sequence represents a single place on the graph. The graph of a sequence is not continuous. In this chapter, we'll use bars so that we don't confuse the graph of a sequence with the graph of a function. Let's begin with a number sequence. Instead of saying for every x there corresponds a y, we're going to say that for every counting number, that is positive integers, there corresponds a number. Our inputs are just counting numbers and do not include every point between the counting numbers. We don't have variables in a sequence, we have terms. So we'll say the numbers in a sequence are called terms and are referred to as the first term, the second term, etc. We use t sub 1, t sub 2, t sub 3 to refer to the first term, the second term, the third term, etc. When you see t sub 1, you can read it as the first term, or you can read it as t sub 1, meaning t with a subscript of 1. I'm going to use a definition a bit different than the one in our text. I want to emphasize that successive terms in an arithmetic sequence have a common difference. So, in an arithmetic sequence, the difference between successive terms is the same. The difference could be positive, negative, or 0. It does not need to be an integer. If the difference is positive, then the terms of the sequence will get larger, such as 2, 4, 6, and 8. If the difference is negative, then the terms of the sequence will get smaller. For example, if we start with 100 and go to 50 and 0 and negative 50. If the difference is 0, then all the terms of the sequence will be the same. Negative 3, negative 3, negative 3. Press pause here if you need to copy some of this down. Here's the sequence described in your book about the skydiver. In the first second of his fall, he fell 16 feet. In the next second, he fell 23 feet more than that, or 48 feet. In the third second, he fell 80 feet, and so forth. Now, in a vacuum, the descent of the skydiver would get faster and faster, but because our planet has an atmosphere, the speed of the descent is affected by the friction of passing through air. Oh dear, we seem to have gotten into some physics. Let's back out for now. I said in a previous slide that we talk and write about the terms of a sequence with the letter T and a subscript. However, a sequence will not typically be presented in a table like this. It will simply be a list of numbers, like the ones in the upper row of the table, like this. In a geometric sequence, the ratio between successive terms is the same. The ratio could be greater than 1, and that would make successive terms larger and larger. The ratio could be between 0 and 1, making successive terms smaller. The ratio could be 1, making all the terms the same. And if the ratio is negative, then the signs of the terms will alternate between being positive and negative. Pause here if you need to copy this down. And just for your thinking pleasure, yes, there are many types of sequences. Just about any rule that can generate an equation can generate a sequence. The difference between a sequence and a function is that the way terms are generated begins with which term we are looking for. For example, if we want the fourth term of the sequence, we'll start with the number 4 and apply a rule to get the fourth term. We never ask for the 3.5 term of the sequence. So when graphed, a sequence is never a continuous line or curve. It's just dots, that is, places on the coordinate system. And again, to remind ourselves that we're talking about sequences and not a function, we're going to graph with bars and not use dots. There can be exponential functions that could be sequences. Fibonacci generated the Fibonacci series is a sequence. Now, there are 2 tests you can apply to decide if a sequence is either arithmetic or geometric. You'll need to do these 2 tests between 2 different pairs of terms. The terms do have to be next to each other. In the case of an arithmetic sequence, the difference between the terms is always the same. The nth term minus the previous term, the n minus 1 term, is the same. The difference between any term and the one before it should be the same. Add this difference to a term to find the next one. In a geometric sequence, the ratio between the terms is always the same. So a term divided by its previous term is always the same ratio. You will multiply this ratio to a term to find the next term. Well, what if it's not arithmetic or geometric? Well, look for patterns. And that might help you decide what the formula is. And if fractions are present, try restating fractions with a common denominator. So let's talk about writing the formula for an arithmetic sequence. This is similar to writing a linear equation. Our terms are 1, 2, 3, 4, and 5. The first term, the second term, the third term, etc. is in the top row. And the terms are 5, 10, 15, 20, and 25. The arithmetic sequences are similar to writing a linear equation. Here's a table for a sequence. You typically will not find presented this way. We won't put sequences in tables. But I put the number of the term in the first row and the terms in the second row. Notice that for this T chart, instead of labeling the rows X and Y, they are labeled N and T sub N. And I ask myself the same question that I do for a linear equation. What must I do to 1 to get 5? And to 4 to get 20? The answer is just multiply by 5. So the nth term of the sequence can be found by multiplying n by 5. This formula gives me each term of the sequence. This is a more typical presentation of a sequence. Remind yourself that when n is 1, t sub 1 is 17. So what must I do to 1 to get 17? And note, the terms get smaller, and the difference between them is -4. From one term to the next, I add -4, and I get the next term. So I start with 17 and subtract 4. But that would be the second term. How can I make my formula not subtract anything for the first term? And the answer is multiply -4 by 0 for the first term. So if n is the first term, then n minus 1 is 0, and 4 times n minus 1 is also 0. I won't be subtracting anything from 17. Now, this needs a bit of simplifying. And yes, this formula will give me every term of the sequence. Before we go on, I want to note that your calculator does have a mode for sequences and sequence notation. You should be aware of it and that it can do some cool stuff. Feel free to experiment with it after I show you this, but since our look at sequences is an introduction, I'm going to return us to our function mode after that. Here's what you should know for now. Pick up your calculator and follow along. If you press the mode button, you get the screen you see here. Navigate to sequence mode and select it by pressing enter. To get back to your home screen, press second and quit. Now let's have a look at some other screens. Press Y equals, and you get a lot of options. In this screen, if you need n for your equation like you would need x in a function mode, then press the shortcut X button. But because you're in sequence mode, you'll get n, the number of the term, instead of x. Now, because this goes much deeper than we need for this introduction, we're going to back out of sequence mode and return to function mode. Navigate onto function, press the mode button again, navigate onto function and press enter, then second and quit to get back to your home screen. To enter the sequence we want before we were interrupted, let t sub n be y equals, and use x for n. And I'm doing that in the y equals screen. And yes, those are the same buttons we used in the sequence mode. Now, you can go to the table and see it laid out vertically. Remember, some of the elements of this table don't apply because we are talking about sequences. There will not be a zero term, so every line of the table where the x value is less than 1 should be ignored. Here's a geometric sequence. These are easier to write than arithmetic sequences. First, notice that each term in this sequence is doubled. The ratio between the terms is 2, and then notice that the ratio is powered up for successive terms. The way to not multiply the first term by the ratio is to make the power on the ratio 0. The nth term, which is 1, minus 1 would be 0, and 2 to the 0th power is 1. So I would be multiplying 5 by 1. That would be the first term of the sequence. The first term goes here in your formula, and the ratio goes there. We'll talk more about these formulas in successive lessons. Here's example 3. We just need to find some terms of the sequence. It is neither an arithmetic or a geometric sequence. Can you write a formula for it? The numerators start with 1 and increase by 1. The denominators start with 2 and increase by 1. Another way to think of this is the denominator is 1 more than the numerator. N, the first term of the number of the first term, corresponds to the numerator. This formula will do it. Homework. Problem 4n is a mystery. Do you recall my suggestion to write a string of fractions with a common denominator? Here it is. And now do you know what to do with it? Is it arithmetic, geometric, or neither? For an arithmetic sequence, the difference between the terms must be the same. For a geometric sequence, the ratio between the terms must be the same. Can I add something to each term to get the next one? Or must I multiply something to each term to get the next one? I'm not going to give this one away more than I just did. Number 8 sometimes trips students. How can a sequence be both arithmetic and geometric? Well, we know two consecutive terms. So if it's an arithmetic sequence, then we want to know the difference between those two terms. For 8a, the difference is 40. Now can you find the first term and the last terms? What's 40 less than 10? What's 40 more than 50? But if this is a geometric sequence, the ratio between the terms is, what must you multiply 10 by to get 50? The ratio between the terms is 5. Now you can calculate the first and the last terms. Here's those two questions again. If arithmetic, then the difference between the terms is what? If geometric, then the ratio between the terms is what? Let's summarize. A number sequence is an ordered set of numbers with one number for each counting number. The numbers in a sequence are called terms and are referred to as the first term or t sub 1, the second term or t sub 2, etc. In an arithmetic sequence, the difference between successive terms is the same. In a geometric sequence, the ratio between the successive terms is the same. I didn't put the formulas we found here on our summary. We'll look a bit more at formulas in the terms the formulas for the terms of the sequence in the next couple of lessons. That's all for now.